Welcome everybody to a new webinar of the Banking and Innovation Foundation. So we are gonna give like a few seconds so we give time for people to join in us. And so we give this time for people to join, okay? Just a few seconds. Okay, I think we can start. So welcome to a new webinar of the Banking and Innovation Foundation. This webinar is the result of the meeting that we held in June 2024, where we gathered around 40 experts to discuss about the challenge of water is facing. Today, it is a real honor to have David Sedlak, Professor of Environmental Engineering at the University of California and Berkeley. Welcome, David. And I just gonna give you a few lines about David because I think he is the star and he has the knowledge to share with all of us about the future of water. And just to give you about his background, David his work has been focused on developing cost-effective, sustainable methods for local water sources. His research covered water reuse, urban treatment, and he has contributed a lot to urban water cycle management. And he has written several books like Water 4.0 and Water for All. So welcome, David, and give up your thoughts with us. And thank you so much for being today with us. And we will have a debate when David finishes his talk. Okay, thank you so much.
Okay, thank you everyone for joining us today. Let me bring my slides up here, and we can begin. So, as you just heard, there was a Future Trends Forum or a meeting back in June where we talked about the idea of water, our vital resource, in jeopardy. And you can read this report on the Bank Inter website. But for me, I had the opportunity to really enjoy this meeting for two reasons. The first reason was that unlike many of the times that I've met with other experts to talk about water, it was a holistic view. It wasn't just thinking about freshwater supply or impacts of water on and water pollution on ecosystems. It was really looking at the whole puzzle of water challenges that the world faces. And the second thing that I thought was really interesting about that meeting was that it brought together a lot of experts from Spain and the Mediterranean region. And I saw the connections between Spain and Mediterranean countries and where I live in California. And so I learned a lot about the approaches, the innovative approaches that people are taking to address water crises and water scarcity. And I was able to share some of the things that I've learned in my time here. And I think this kind of international collaboration and sharing of ideas is really important, especially in terms of addressing complex problems like water. And so at that meeting, I gave a talk, and you can find this talk on YouTube or on the website for the foundation. And it was a short talk on what I saw as the ways in which technologies might lead to more efficient water use and help solve some of the problems of water scarcity in the future. And what I'd like to do today is build upon that, because it was only a short talk of about 15 minutes. And also it was something that was really intended to frame the overall meeting. And I'd like to dig a little deeper today to think about the different approaches that we can use to address water. And the first one that I'm not going to have a lot of chance to talk about today, but I wanted to emphasize is really important, is the idea of using water efficiently. So this is a photograph of a drop nozzle irrigation system, which saves about 20 or 30% of the water being applied to a farm field relative to the old-fashioned sprinklers that people use. And this technology and technologies like drip irrigation have tremendous potential to unlock sources of water by not using as much water to grow our food and to run our industries and to keep our cities going. And I think it's very important to remember that before we think of any kind of new investments in cutting edge water technology, we should first investigate the policy changes that could make water use more efficient and different established technologies to use water conservation and water use efficiency to make water more efficiently used and to alleviate scarcity. And that's discussed in Water for All, my latest book, but I don't have time to talk about it today. And I really wanted to focus on the ideas of technologies. And the technology that I think that we're all most familiar with, or the approach that we're most familiar with, is something that water experts refer to as unconventional water resources. This idea that we could turn to technologies like desalination and water recycling to create new water sources and new water resources where using sources that otherwise wouldn't be accessible as a freshwater source. And I'll show you today where this has come and how it's being used, but I'll also try to talk about the future and what opportunities there are, especially for Mediterranean countries, places that share a similar climate and that are facing scarcity, and that have already addressed some of these issues with water use efficiency. But the third topic that I want to talk about today, and one that I didn't really get much of a chance to talk about last June, is this idea of rethinking our existing water infrastructure. And what we're going to see in the future, in my opinion, is large investments in water infrastructure. And we have a choice. We can either make these investments the way our grandparents and previous generations made these investments, building dams and reservoirs and canals, or we can take knowledge that we've accumulated over the last few decades in the use of nature-based systems and use nature and green infrastructure in harmony with our existing infrastructure to make it more efficient. And I want to also emphasize that in this talk today. So let me start by thinking about this issue of unconventional water resources. And if you look at the photograph in the middle of the screen, you'll see a picture of spiral wound membrane cartridges. This is the technology of reverse osmosis that has been developed over the last 50 years and has gotten better and better and more efficient and less expensive and less energy consuming, and is now starting to have a very large impact on the way in which we think about unconventional water resources. And the most obvious place to think about this is the topic of desalination. So this map shows you the locations of the big desalination plants that have been installed around the world. And the colors show you the different types of applications. The size of the circle is proportional to the size of the treatment plant. And so if you look at this figure, the first thing you'll notice is that the main application of desalination is for municipal water supply, for water supply for cities. And there are still very few that use this technology for industry or for irrigation, for agriculture, or for power plants. The other thing you'll notice if you look at this figure is that most of these desalination plants are located on the coast. And I'll emphasize that a little bit more by showing you a separate figure produced by a different group showing where the desalination plants are in the EU. And you'll see that the majority of these are on the coastline. And in the case of the European Union, most of them are in Spain. So certainly this idea of technology, of desalination as a water treatment technology is familiar to people who live in Spain and live around the Mediterranean. This technology is being used for taking seawater and making it into fresh water. But most people around the world don't live within 50 kilometers of the ocean. Most of the world's population is located inland. And so we need to think about this idea that seawater desalination, which is a mature technology, which is often the least expensive next water resource for people, as evidenced by all the treatment plants that have been built in Spain and Australia and around the Middle East, that this technology needs to spread beyond the coastline. And when we think about the idea that if desalination is going to have a bigger impact, it's going to happen away from the coastline where the seawater exists, you might say to yourself, well, how can you use desalination if you don't have access to the ocean? So one way to start thinking about this is to look around the world and see the locations where people exploit groundwater as a resource. And particularly, I'm thinking about deep groundwater. So the figure on the left is a map showing you Libya's Great Man-Made River Project. And many people are not aware of this, but it's one of the largest water projects built in the world in the last 50 years. It produces somewhere around 6.5 million cubic meters of water a day, which is a huge amount of water. It gets the water from the middle of the Libyan desert, where you wouldn't expect there to be a lot of water. But there, the system consists of a series of wells drilled to depths between about 500 to 1,200 meters, which pumps water out of an ancient sandstone aquifer. And that aquifer has a lot of water in it. It turns out that that water is not very salty, but it shows that large water resources projects can be built where deep groundwater is essentially mined out of the earth and used to provide a water supply. And this is one of the main water resources that's used for the cities and the farms on the coast of Libya. And it's estimated that this will last for somewhere in excess of 100 years. So this may not be a renewable resource, but it's a resource that people exploit because it can provide large quantities of water. And when we look around the world, we see that these deep groundwater aquifers, which are currently not being exploited, exist just about everywhere. So this is a map from the US Geologic Survey showing you the depth to groundwater of these deep inland groundwater resources. And in the case of the United States, these resources are not suitable for drinking because they contain salts. So when water sits underground for thousands of years, it picks up salts from the dissolution of the minerals underground. But the amount of salts is much lower than the amount that's present in seawater. And so if you can pump this water out of the ground and desalinate it, it's a way to use desalination technology far away from the sea. And I want to just give you a brief example to show you what I mean by this. I want to show you an example from California's Central Valley. So if you look on the left-hand side of the United States, on the West Coast, there's a region called the Central Valley, which is the main agricultural area of California, and it's home to several cities, a population of about 4 million people overall. And the farms in this part of the Central Valley, or in this part of California, the Central Valley, have been fighting the issue of salt accumulation in the soil and the groundwater for the last 50 years. And so in the year 2016, a group of farmers came together and created something called the Central Valley Salinity Alternatives for Long-Term Sustainability, or CV Salts program. And they proposed the construction of a series of small desalination plants, which they called desalters. And these desalters would take the salts out of the groundwater and send them in a pipeline. And you can see the map on the left showing the pipeline. It was a 450-kilometer long pipeline. They'd send them all the way to San Francisco Bay, where they'd be disposed of in the ocean. And this project, the first time I heard of it, I was pretty surprised by it because it was quite expensive. The overall capital cost was somewhere around $11 billion. And the water that it was producing would cost somewhere around $2.6 per cubic meter, which is more than 4 or 5 times the price of seawater desalination. But just the idea that a group of farmers and cities were thinking about using inland desalination as their next water supply and were willing to consider investments on the scale of billions of dollars, got us thinking in terms of research. And one of the things that we quickly realized was that over half of the cost of this project was the cost of dealing with the salts that are produced by the desalination process. So desalinating brackish groundwater that has relatively low levels of salt in it, is pretty inexpensive these days. The real cost of this project was getting the waste from the process, the salts, and sending them out of the area so they didn't cause an environmental impact. And so what we're seeing in the future are projects that look like this. And I don't intend for anyone to really get a lot out of this image unless they're already an engineer working on this topic. But the general concept I wanted to relay is that if we can take the brine from inland desalination projects and make it into something valuable, that is, if we can valorize it and turn it into industrially useful products, we may have a way to access this unconventional water resource of inland brackish groundwater. And this is a figure from my colleague Pei Xu at New Mexico State University, where they've been working on a brine valorization process for brackish groundwater that's being pumped out of an aquifer near El Paso, Texas. And one of the keys to this is that you can take the salts that are in groundwater, and if you can separate the ions, you can make things like sulfuric acid and sodium hydroxide or caustic, which are valuable industrial feedstocks. They can be used in many different industries, and then you don't have to pay the price of disposing of these wastes. So I see tremendous potential in the future for inland brackish water desalination to complement the seawater desalination that we're currently doing on the coast. The second type of unconventional water resources that I thought I'd share with you today is this idea of potable water reuse. And by potable water reuse, we mean taking the sewage that goes into a sewage treatment plant, putting it through the normal conventional sewage treatment process, and then putting it through an advanced treatment process. And you can see a photograph here of part of the advanced water treatment process that's used in Orange County. This is an area between Los Angeles and San Diego in Southern California. And if you put this water through the advanced treatment process, you create a water that is so clean that it can be used as a drinking water supply. So the groundwater replenishment system, which is in Orange County, takes about 0.28 million cubic meters a day of wastewater. This is maybe like something like 5 or 10% of that project in Libya that I talked about earlier. So it's a significant amount of water. It's enough water for several million people. And it puts it through reverse osmosis, RO, which is the process that's already used for seawater desalination. And then it applies a second step called advanced oxidation to degrade any chemical contaminants that make it through the reverse osmosis membrane. And the cost of this project, about 70 cents per cubic meter, makes it competitive or even less expensive than seawater desalination. And so Orange County in Southern California is currently recycling essentially all of their wastewater and putting it back into the drinking water supply. And the way they're doing this is by injecting it into groundwater wells. You can see on the figure on the right here, one set of groundwater wells in a place called the Talbert Barrier. And they're also putting this water in a pipeline and pumping it up to a place called the Anaheim Lakes and putting it in the lakes. And from the lakes, they percolate into the ground and feed the groundwater system. And then this whole area uses groundwater that used to be sewage as their water supply. And this idea of the groundwater replenishment system, which has been operating since 2008, and then before it, there was another project that started in about 1976. The idea that this is a cost-effective and safe way of increasing the drinking water supply has inspired the city of Los Angeles and the city of San Diego, and both cities have committed to the same sorts of projects. So over the next 2 or 3 decades in Southern California, there won't be any more sewage going to the ocean. All of the treated sewage is going to go into the water supply, and the majority of it is going to undergo this process of potable water reuse. Now, this process is not as common in Europe. There's a small project in the sand dunes of Belgium that is being used to do this. I think arguably the water supply for Barcelona, the water recycling project that's on the coast in Barcelona, is very similar to this project in terms of the technology and the injection of the water into groundwater wells near the coast. And so we think that this process is going to become a lot more common in the future. And in the US, we're even talking about bypassing the groundwater recharge step and taking the highly treated water from the advanced treatment plant and putting it directly into the water distribution pipes, a process that's referred to as direct potable reuse. And there's a direct potable water reuse project being built now in El Paso, Texas, and there are several projects being proposed and investigated around the country. But this is an area of massive investments of resources in the United States. It's a process that's been used successfully in Singapore. Essentially, all of the treated wastewater in Singapore undergoes a very similar process, and it's being used in cities like Perth in Australia. So I think this is something that you'll see more of in the Mediterranean region in the future. The idea of water recycling or potable water recycling is quite compelling to us, but we also see that it doesn't fit every city and every place. And one of the themes of my talk that I'd like you to take away is that there's no one solution that works everywhere. We need a whole toolbox of possible solutions to water scarcity. So another approach to water recycling is to do water recycling at the building scale. So the cartoon on the left here just gives you an idea of like how you might think about recycling water without sending it all the way to a sewage treatment plant. You could basically collect the water that's generated, the dirty water that's generated within a building, and treat it in the basement of the building, and then send it off for reuse within the building or in the neighborhood. And I wanted to highlight on the right-hand side here 2 cities where this approach is being pursued and is relatively successful. The first one is the city close to where I live of San Francisco, where now when tall buildings, apartment buildings, and office buildings are built within the city, they're required to have an in-building water recycling system. And these are some pretty high-tech approaches to wastewater treatment and advanced treatment. They look like miniature versions of that treatment system that I showed you a few minutes ago in Orange County. And this has the potential to start scaling up and being used in other cities. And it's being investigated in places like New York City and Austin, Texas, and Los Angeles and Phoenix. The figure on the photographs on the bottom, though, are from the city of Bengaluru, or what used to be called Bangalore in India, where they're also facing water scarcity and where the city also requires that new buildings install in-building water recycling systems. And while the first generation of in-building water recycling systems in Bengaluru wasn't as sophisticated as the systems that are used in San Francisco, they're starting to catch up in terms of the technologies, and people are getting to the point where they're reusing the water in the building for bathing and other types of potable purposes. So you could almost think of a building being a closed system where the water is used over and over again. And I was fortunate enough to be part of a Spanish-led team that investigated this issue of in-building water recycling a couple of years ago. We published a paper on this, and I'd be happy to share it with anyone if they send me an email after the lecture today. But we found that you could put these in-building water recycling systems in existing buildings. They would take up a relatively small fraction of the footprint of the basement of the building. And when you think of the cost, the CapEx cost, the capital cost of building them, and the OpEx cost, the cost of operating them, the bottom line is that these systems pay for themselves within 10 years. And so for the resident of a building, this could be a cost-effective savings, much in the way that when you install solar panels on the roof of your building, they pay for themselves in the reduction of the bills that you pay for your electricity. Now, I want to turn my attention now to that other approach for expanding our water supply of relying upon changing our existing water infrastructure. And the reason I want to think about changing our existing water infrastructure is that it's becoming painfully clear that our existing water infrastructure is not able to protect us from our new climate. And I think Spanish people in the audience are well familiar with the floods that came last year in Valencia and the Andalusia and other parts of the country. And this idea that we've been seeing rainstorms and natural disasters, these unexpectedly large rain events, is becoming understood to be connected in some ways to a changing climate. And here in California, we see the same kind of thing. Just 2 years ago, we had severe rainfall in the winter to a point where it flooded an area of Southern California called the Tulare Lake, which had disappeared over 100 years ago when it was turned into farmland and when the water had been exploited. And in the large rains and snows that came in 2023, we saw, or in the winter of 2022, we saw so much water that the Lake Tulare returned to that area, flooding many farms and also a number of homes. And so in order to protect our cities from the kind of damage related to these severe storms, we need to rethink parts of our infrastructure. What is somewhat puzzling to people is that at the same time that we see these larger storms causing flooding, many of the same regions are experiencing droughts. So Spain has had these large rain events in certain seasons, but Barcelona is still worrying today about a drought because that rain fell in a very short amount of time and the infrastructure wasn't able to capture it all. And the same kind of thing has been happening here in the Western United States as we look at the Colorado River Basin, for example, one of the most important water supplies for most of the Southwest United States. We see the size of one of the two main reservoirs, Lake Powell, shrinking and shrinking over time. And this idea that our existing water resources, our infrastructure is unable to provide us with enough water is really related to a concept that climatologists are referring to as aridification, the idea that as the climate changes and it becomes hotter, the rates at which water evaporate increase. So even if you're getting more of these large rain events, you're unable to fill your reservoirs because the water's evaporating so quickly. And so the key to this, and in many ways, I think one of the areas that I think we'll see a lot of activity of in the future, and I think there's great potential for, is to take our existing infrastructure and not necessarily make it bigger or build more dams and reservoirs, but to figure out how to get more of this water that falls during these large rain events underground into aquifers where we can store it. And here in California, farmers working with water resource specialists have been working on an approach that they refer to as flood managed aquifer recharge. The idea that when we get these large storms, and in California, our Mediterranean climate is such that we get our largest storms during the winter time, we allow these floodwaters to flow into farm fields, in this case, an orchard, but the same thing can be done in all kinds of other fields. And as long as the trees and plants are dormant at the time, they do just fine being in a flooded environment. And this water is allowed to percolate into the ground where it recharges the groundwater aquifer and it can be used in a future year. And this is an area that I think has a lot of potential in agricultural communities to provide water supply. But increasingly, we're starting to think about the idea that this same concept of intentionally flooding land and getting water to percolate into the ground may be useful in cities. So this is an artist's conception of a project that's currently being built in Los Angeles in a place called Sun Valley, which is in an area that's directly above the drinking water aquifer for the city of Los Angeles. And this is a neighborhood where the soil and the ground is such that water percolates very quickly. And so what the city is doing is, instead of sending large storms into river channels and into storm sewer pipes, they're sending the water from these large storms into a constructed wetland. You can see the wetland at the top of the image. And then from there, it goes into a percolation pond. And that percolation pond allows water to get into the ground and to recharge the groundwater aquifer. This particular approach works really well in Sun Valley because the geology is very favorable. But I think increasingly we can start to learn from other cultures where people have dealt with the kinds of new climate that we're facing, the so-called monsoon-like conditions like India, to examine technologies that a lot of people have forgotten about, things like dry wells and step wells and infiltration galleries, and use those as a way to couple our existing water infrastructure of reservoirs and canals that protect us from flooding with this idea of capturing the water instead of letting it flood our cities, using it as part of the water supply. So in summary, I want to just share with you a few closing thoughts on the challenge of managing water in a changing climate. The first thing that I want to emphasize is that there's no single solution to water scarcity. Water scarcity is going to be different in every place. Every city's institutions, every city's geology, geography, population is a little bit different. So we need as many tools as possible in our toolkit to solve these problems. The second thing, and what I talked about in the middle of my talk, is this idea of unconventional water resources. And I believe these have great potential. They're just not an abstract idea. They're something that people really are using today. And so I showed you at the beginning of the talk that seawater desalination is a very mature technology. And in many places, it's the least expensive next water supply. Now, there are concerns with seawater desalination. It tends to use a lot of energy. There are concerns about the brine that's produced when it mixes into the ocean. But these are things that are going to continue to be attractive to water resource managers, and that we have to figure out how to make them work in a sustainable manner. I also told you about centralized water recycling. I gave you the example of how it's being done in the Western United States with potable water recycling, the idea that you can use an advanced treatment system and make this water safe enough for drinking. And I told you that it's being used throughout the Western United States and parts of the Eastern United States, in places like Singapore and Australia, and even closer to home for you in Barcelona and in Belgium and in a few other places. I think we'll see more of this in the future. And then I also talked about this emerging technology of building scale or decentralized water recycling, where you can recycle water at individual buildings. And I think that this is something that has a lot of potential, especially in places where the infrastructure is not already built out. For example, in sub-Saharan Africa, where we have cities, mega cities growing very quickly, this may be the approach that people use to leapfrog around the older approaches of centralized wastewater collection and treatment. And finally, I ended the talk today thinking about nature-based solutions, and I gave you the example of enhanced groundwater recharge, either on farms with flood-managed aquifer recharge, or by building engineered systems for capturing stormwater within cities, which would reduce the potential for flooding, and then getting water into the ground where it can contribute to the water resources. So Thank you very much for your attention today. I'm looking forward to discussion with you. And again, anyone watching is welcome to follow up with me. My email is just my last name, sedlak@berkeley.edu. Thanks, and back to you, Marcy.
Thank you, David. Thank you so much. It's a real pleasure to learn from you. It's amazing. So I have some questions here from the audience. And if you want to make more questions, please write it down. Here we go with the first one. What role should water governance and integrated water resources management play in balancing technological innovation with social equity and ecological resilience, ensuring that techno-optimism does not result in unintended inequalities of environmental degradation? It's a long one.
Well, thank you very much for that question. I think it's an important question. I chose to give you a talk more on the technology side. I'm a technologist by training. It's the area of my research, and part of the reason why at the beginning I had this idea of water use efficiency shown on the slide is that I think that the least expensive, most impactful, and most obvious way to address water crises is through integrated water management. It is through changes in policy. It is through investigating water rights. And all of those things are certainly essential. But I want to emphasize that those things have existed for 50 years or longer. And the problem of trying to solve our water scarcity problems only through policy solutions is that we have a lot of experience that shows us that policy solutions are often unable to solve these problems. They often allow the problems to develop to the state of crisis. And that's an area where I think we shouldn't give up, but we should recognize that politics and economics and just the way that politics works means that these will not always solve our problems. I love the idea of re-examining equitable water rights allocations. I love the idea of thinking about water use efficiency. But when I look around the world, and I'm a realist, I see that it often fails. And I think we need to rededicate ourselves to solving those problems. But I think they're one of the main tools in the toolbox that we should investigate, but we shouldn't rely on it alone. I also think that sometimes these technological solutions that I talked about today can help open up the discussions again about these other needs that we have for our infrastructure.
Okay, thank you. Moving now about on your background on technologies, what are the main emerging technologies that are revolutionizing water management in urban environments?
Okay, well, the main technologies, I think I went through the ones that I think are most impactful today. And they mainly come down to this innovation of the reverse osmosis membrane. So I showed you one example, which was seawater desalination, these big desal plants like you're familiar with in Spain. But that same reverse osmosis technology has been critical to potable water recycling, which is the other example I showed you. And it's also been important for household water treatment. So if you look in places like China and India, you see that increasingly people are installing these small reverse osmosis systems underneath their sink to purify the water that they're getting from their water utility because they don't trust the quality of it. And so I think certainly one of the main technologies that's having an impact on water resources is reverse osmosis and reverse osmosis treatment at different scales, because it's become cheaper, it's modular as a technology, and there's a whole industry that supports it. The other one that I talked about today is this idea of nature-based systems, and I gave the example of groundwater recharge as a nature-based system. But I do think, especially when we get into agricultural water use and water to restore ecosystems, the idea of using our knowledge about hydrology and ecosystems to to use water more efficiently. Sometimes people refer to this as the slow water movement. I think that has tremendous potential, and we'll see more of it in the future.
Okay. Here I have one crazy question. H2O, do you think it would be possible and feasible to manufacture water on an industrial scale in the future?
Yeah, it's a great question. I don't think it's a crazy question. I think that in some ways, desalination technology does allow us to manufacture water. We can take seawater, which is not fresh and not drinkable, and make it drinkable. We could take this brackish groundwater and make it usable. We can take sewage and make it usable. So essentially, we could take the water content of anything and turn it into fresh water. So if you're a fan of science fiction and you watch Dune, you saw that they would, when they would run across anything, like when someone would die, they would take all the water out of their body and reuse it. That technology's here. It's just that the cheapest way to do it is to look towards water, seawater, or brackish groundwater, or treated wastewater. The other one is people are quite excited about is this idea of pulling water vapor out of the atmosphere. Sometimes this is referred to as atmospheric water harvesting. If you're not familiar with atmospheric water harvesting, you're probably familiar with an air conditioner. And when you have a cold coil in an air conditioner or a heat pump, the water condenses and you capture that water. Normally, you have to get rid of that water because it'll make a mess in your house. But there are companies set up to take this water and reuse it. The challenge with that is that that is incredibly energy intensive. And so we already have the technology needed to manufacture water. The cheapest one is desalination, and that's why it's spreading. And I guess the other one is the hydrogen economy. When we burn hydrogen that we're using as a fuel, the byproduct is indeed water. It's just that we're not yet burning enough hydrogen to produce enough water to be useful to us.
Okay. Another question that in California, you have already been using water reuse for citizens. So what do you think? How we can let me think right in English. How can public accept in the right way those technologies that are going to promote water reuse?
So I've been involved in research with some social scientists on this question of the public perception and the public acceptance of recycling wastewater into the drinking water supply. And the way that they explained it to me, and it makes a lot of sense to me, is that all new technologies face a period of what's referred to as legitimization. So something that's unfamiliar to the public is kind of scary. And unfamiliar technologies have this period where the public has to make up its mind whether this technology is legitimate or acceptable or illegitimate and should be rejected. And we saw in the 1970s and 1980s a new technology of nuclear power fail to undergo legitimization. That is, the public lost faith in it, the public thought it was dangerous, the public thought it was illegitimate. And so the progress of nuclear power in many parts of the world slowed down quite a bit because the public didn't accept it. We've also seen other technologies successfully undergo this legitimization process. And one of the classical examples is commercial air travel. When people first started flying in airplanes commercially, there was a period when the public was very apprehensive about it, but they managed to create legitimacy. And so studying these past examples of legitimization, we've seen that the way in which potable water recycling undergoes legitimacy is that the institutions that do it have to build up public trust. And one of the ways that they build public trust is through transparency. So the utilities that have successfully engaged in potable water reuse have a lot of sharing of information with the public. They don't try to hide things. The second thing that has to happen is that the public has to trust the institutions that are responsible. Not only do they have to trust the utility, they have to trust the government who's regulating it. And in these days, when the public is losing faith in institutions, this is a real challenge. So we have to pay extra attention to the legitimacy of our institutions. And finally, the thing that the public really has to start to understand is that this is a technology that benefits them. And so if you can see that it's important to the long-term sustainability of your community, if you can think about it as being the right thing to do, not something that someone is forcing you to do, that is part of this legitimization. And I guess the one that I forgot also is that the public has to become familiar with it. And so, for example, you can see here, I have on my bookshelf bottles of water from Singapore and from Orange County, where the utility takes this recycled water and they bottle it and they give it out to the public so the public can try it. And when you try it, when you drink it, it tastes like any other water that you might drink. It tastes like the stuff that you buy at the store when you buy bottled water, and that helps the public accept it because they have personal experience with it.
This is a good example. So do you want to make a last point before we close the webinar?
Oh, I don't know. I think in these days of being online and watching webinars, I'm very proud of anyone who's made it through the whole 50 minutes. And I just wanted to say I enjoyed last June at the meeting. I've enjoyed interacting with people at the foundation, and I hope that you appreciated the webinar. If you'd like to dig a little deeper, my book Water for All came out in 2023. There are also ways to reach me. As I said before, feel free to reach out to me at my email, sedlak@berkeley.edu.
Thank you so much, David, for all your collaboration with us, your support. Muchas gracias a todos por asistir a este webinar y os esperamos en el siguiente. Tenemos otro el día 27 de febrero, donde vamos a hablar con dos empresas españolas que están usando la tecnología precisamente en producir agua desde el aire y también utilizando nuevas tecnologías a la hora de lavar los pantalones vaqueros, los jeans, como son Yanología y Genac. Muchísimas gracias a todos. Thank you so much, David.
Bye. Thank you, and have a great evening, everyone.
You too, bye.